Hey guys and girls, welcome back to another beautiful video on this beautiful channel, beautiful day. Today we're gonna make the ultimate beautiful dynamic array with a template dynamic array, and this is the absolute ultimate template array. So what I'm gonna do is I'm gonna make a new project, the array project, and just anything, you call it whatever you want. I'm making a new project because I don't want to clutter everything. You can do this in your same project file thing that we always use, or you can do it wherever you feel like it. It's just that you're gonna need to make some CPP and header files. So what I'm gonna do, I'm going into my examples and I'm gonna write example 64. I think we're at. That's pretty crazy, isn't it? We're pretty far ahead. And I'm just gonna wait, what? Let me just do that. Oh, sorry, example 64. Oh my god. Okay, there we go. Go to next. Go make an empty project. Remove that. Whatever. Finish. And then quickly. Come on. Make a new item. Per usual. A main file. Make a new header file. Only a header file. Call it the array. Just the, I usually call it the array. And then make a class the array. Just do that. There you go. Alright. And then template type name T. You can call this anything. I don't know if I said that before. You can say whatever you want. It's gonna, as long as you just specify that. I usually use T for template. Everyone does. Kind of, it's a generic thing to do. Include IOStream int main. Return 0. Using namespace std. I've been called dumb for not using namespace std, so I'm going to start doing it because I don't want to be called dumb, and it is kind of dumb to not use it when you don't have to, worry about it. There are points where you don't want to use it, but when you can, you should. Anyway, include the array. The array. Wasn't that right? Oh, the array. That is okay. We're gonna do that. That's it. And we're gonna make a. We're not gonna do anything else. This is it. Private. And then public. Watch my old videos as usual, just to get a hang of stuff I'm gonna do here. I'm gonna explain stuff always because these are tutorials, but I'm gonna do it a lot less. So I'm gonna make a illustration as well later. The array. No, what am I doing? Yes, I am doing it correctly. And then these are supposed to be in public, but I'll transfer them. The array, the structure. We'll do this. And then the array. And that's good. Int size equals 5. I always do size in cap. I can do cap. And then here we're gonna have a, what is it? Operator. Boom. T reference operator. Bam. Const int index. That's an operator we're gonna use. We're gonna create something pretty important here as well. We're gonna do a D array. You always want to do this, okay? You always, trust me, you always want to do this. Const D array object. You always want to make a copy constructor, because when you're creating D arrays in, for example, a character class, say you're making a character, you have an inventory, and your inventory is a D array, and when you're creating several characters, you're copying them between each other, you're gonna get a bunch of problems if your dynamic array doesn't have a copy constructor, because it's gonna use shallow copying on your dynamic array, and that's gonna basically, what's gonna happen is when you copy two characters and they both have their own dynamic arrays, the one character's dynamic array is gonna be deleted, and the other one is gonna be pointed to the other ones and stuff. There's gonna be a lot of mixing. when you do this, create its own copy constructor, what's going to happen is they're both going to get their own separate ones with their own separate copied data. That's what you want to do. So I'm just going to say that, and then what I'm going to do is I'm going to do void operator boom const the array object. So that's a operator thingy. That's good. There's another way you can do this. You can return a t element in here, so you can chain a bunch of these assignment operators. But I'll just do the simple one. And then what do we want to do? So we can get it, then const int unsigned, because it's optimized. Remember, unsigned get just size const. And this is going to be as optimized as possible. Unsigned cap const the array object. That's good. Private, we're going to have a unsigned cap unsigned number of elements. Difference between unsigned and int is ints can go into negative and positive, but the positive parts is smaller, it's smaller because it can go into negative as well. Imagine unsigned just being that whole period, or that whole amount of numbers that you can keep, and just everything just being shifted to the right onto the positive side. So it can hold from 0 to a much larger positive number, because all of that space that int had for negative is also put into the positive part. So that's unsigned. So we can have a greater number, and we know these will never go into negative, so that's good. Unsigned, and then we have a t pointer the array, or just array, a t pointer array for the most efficient stuffs ever. And then we're good. And then in here we're gonna have a void expand, and then we're gonna do void initialize unsigned from. Not gonna do that. Const unsigned from. So we have an initialize expand. We're gonna have an add function and a remove function. So get size is good. Let me just do the void add, or should we call it push back? No, we add it. We'll call it push, and then const t object, const t reference object, and void remove, and then const int index. That's good. So we'll remove it at an index, push it to the back, and then size. That's good. So let's start creating these. Copy paste all this stuff. We'll go from the top. Here we go. Copy paste this. I'm gonna try to do this quick, okay guys? I'm gonna do this as quickly as I can. Do this as quickly as I can. See, this is just the way you have to write these. So remember, watch my old videos if you don't know really what's going on, because it's important to know. To make dynamic arrays that have template, what is happening? Template arrays, you can't make a CPP file because the template array isn't actually converted or made into an object file. It's not really compiled the same way. It's compiled when it's needed with this special generic type. So when you create one in your game or whatever, it's gonna do this at compile time or at runtime, kind of when it needs to, basically. Otherwise it will make an object file out of this and stuff if it's not a template, and that's why you need a CPP file. But yeah, it's cool that way. It's more dynamic. We'll do initialize and stuff. I'm just gonna do this quickly, and then I'm gonna do everything one after another, so we can just have a nice quick video. Nice quick videos are good. Expand. I bet I'm gonna have a bunch of errors in this later, but that's okay. And guys and ghouls, just bear with me here. This is really important, so gotta do this. Gotta just set everything up so we can start coding. There we go. Now we can start coding. So let's start by coding this. This return. Oh yeah, whoops. We gotta do this as well. Then we can start coding. T operator, void operator, push, remove, unsigned. This return. No. Just return this number of elements. There we go. Can't have that there. Expected a what? Where? Why you do this to me, man? Why you do this to me, man? Size. There's something wrong with the size. Oh, whoops. I'm sorry. I'm sorry, mate. I'm sorry. Why are you doing this to me, bro? Wow, I'm so dumb, bro. I am so dumb. I'm so dumb sometimes. I don't know why I'm coding this stuff. Const unsigned. There we go. I can have that there as well. No problems. Remove. Okay, we're good. Let's start coding, guys. Sorry about that. Okay, so this cap equals cap. This number of elements equals 0. This is just our standard stuff. Initialize everything. This array equals new T pointer array. This cap. It's a new array of that's the max size you can have. These the cap stands for, just to recap, haha, it stands for the unvaluable values. It's just a size, and the number of elements stands for all the valuable data in here. So it's always going to be a big box, and it has that space for you, and number of elements is going to be how many actual valuable stuff we can put in there, or we have put in there. So yeah, this initialize, just going to initialize that from the get-go, from the start. And what it's going to do, we'll see what it does later if you don't already know. This is the copy constructor, so we'll do the exact same thing. And remember, copy constructor is called when an object is created with another object. So we'll use the other object's number of elements and cap, and then this cap, this array equals new. We'll make a new array for this object that we have created using another object, and then we'll copy over everything from the other object. This number of elements, because they have the same number of elements now. This array at position I equals new T object dot array at position I. So we'll just copy everything straight up, and we're good. And we'll initialize it from this number of elements. This is important. If you do it from 0, you're gonna just null pointer everything. This is going to be a for loop going to this number of elements, and we're gonna delete everything first, all the pointers first. Whoops, sorry, this delete this array at position I. So we deleted everything the pointers are pointing to, and then we're going to delete all of those pointers. Delete this array. There we go. For initialize, so what we do is we go from, which we get in here, from to this, the actual end of the whole thing, cap, and we just do this array at position I equals null pointer. And that way we just null pointer everything, because if you delete something that's a null pointer, nothing's gonna happen. If you delete a pointer that hasn't been initialized, you'll get a crash. That's why we do this. So here we go, expand. This is a part where we optimize stuff. This cap, why didn't that work? This expand, where is it? Void expand. Oh, that's why. There we go. Now it's gonna work. This cap equals multiplied equals 2, so it's doubled. This, then we'll make a new t pointer temp equals new t pointer array this cap. So we make a larger array. We go through everything from 0 to this number of elements, and we just this no then temp is pointing to this array at position I. Temp at position I is pointing to this array at position I. So we're just pointing everything to temp to everything that array is pointing to. And then we do delete this array. So we're not deleting all of these elements in array because temp is pointing to them now. Something is holding them for us, so we can delete all the old pointers. And we're gonna make a this array equals new. No, this array equals temp, because temp is a new larger array. We delete the old pointers and we point that array to temp now. And then we'll just do this initialize from this number of elements. So we'll initialize all of those empty points. That's good. This is just gonna if index is less than 0 or index is greater or equal to this number of elements, throw out of bounds. Okay, else if it works, we'll just return this array at position I, and then dereferenced, of course, because we don't want to return the pointer. So there we go, we returned it, and this is the equals multiply. Let's go into the copy constructor for that. Copy everything in the copy constructor, go down, go into your assignment operator thing. This is called when two objects have been created already. They have their own individual data, but for some reason you want to set one of them to the other one. So you want to copy something from another object into one that is already created, and it's going to override and remove everything on the object that is getting the copy, kind of. So it's going to do this cap, object cap, this number of elements. We will, first of all, this is the difference. We have to delete everything in the old one. So for this number of elements, we'll just do this array at position I, delete, and then we'll delete the actual pointers, this array. We deleted all of that. Then we'll set the cap and everything, make a new thingy, go through everything, copy everything over, and then initialize it. And that's basically what we want to do. Yeah. So push is going to do this. If this number of elements is greater or equal to this cap, this expand. So we'll expand it, and then once we've expanded it, we'll say this array at this number of elements plus plus equals new t object. There we go, easy. Remove is we're gonna copy paste this error check, this exception, and we're gonna put it in here, because if the index is greater and stuff, we don't want it to remove that thingy. But if there is an item at that index, then we'll do this array at position index. We'll delete it first. This is the beauty here. We'll delete that object, and then we'll set this array at position index to this array at the end, because we want to shorten it up. So we'll take that object and we will point it to the end of this whole array. So this number of elements minus minus. So that's gonna be good. This number of elements this array at this number of elements equals null pointer. So we'll go down, make it shorter. We will before we make it shorter, we're gonna set the array to the last element. We'll make it shorter first, and then we will set the array to that element, because the last element is always 1 minus number of elements. So yeah, this happens first, goes down one step, and then it puts it to that element, points it there, and then we set the one past the last element to null pointer, and then we're good. And we did this. In some arrays, you might want to remove in an ordered fashion, so you might not want this to happen. You want it to still be ordered, so it will delete everything. So what we can do is we can do a bool ordered delete. If order delete, then we'll do it in one way, else we do it this way, the quick way. So, and we will set that to false from the beginning, so we don't always have to set it. But if it is an ordered delete, then we'll do this: delete this array at position index. We'll delete it, and then we'll make a for loop. This number. Why is this not working now? Why is this not working, dude? Like, I don't get it. Why is this not working? Equals false. This should be fine, dude. Oh, whoops, sorry. Sorry. Go up. Go to your thingy and do that. Okay, so then we're gonna point everything. This array at position I equals this. We'll go to this number of elements actually. Elements minus 1, and this array at position I plus 1. So everything from this index that has been deleted is gonna point to the element after it. So everything is gonna be shoved to the left. If you can see that happening, that's why we're going to the last element. Now after that has happened, we want to delete the final element. Oh no, we don't want to delete the final. We want to set the number of elements to minus 1. And so that's pointing. So the final pointer is also pointing to the final thingy, and this, and the pointer next to it, to the left of it, is also pointing to it. So we want to set the last pointer in the whole thing. This array at position this number of elements minus equals null pointer. Okay, so that's good. That's good. Everything's fine. We're deleting. This is the efficient version. This is the non-ordered delete. So we have a more kind of customizable thing going here. And size, we return the size. So everything is completed, guys and girls. Everything's fine. Now all we have to do is go in here and make a D array of integers, saying my ints or something, and then ints dot add or push. Let's push a bunch of 10s. Let's push a bunch of 10s, more than 5, so that we get a bunch of stuff happening. The first element is 20, the last element is 30, and a random element is 4, and this is 1 or 0, 1, 2, 3, 4, 5, 6. This is the 6th element. This is the 6, 7, 8, 9, 10, 11. This is the 11th element, and this is the 0 element. So now we can try stuff out. We can do this. No, just int dot. What do we want to do? First, we want to print something out. So cout ints at position 0, and then ints at position 6, and ints at position 11. new line. So why is this not working? Because of that. So we'll print all of those out. We'll go through a for loop, get the size. This, I'm so used to this, ints.size. And then we'll just do a cout int at that position. New line. And set position I. We'll make two new lines. We'll cout another new line here. And then we're gonna do some other stuff. We're gonna delete. We're gonna int.remove. Let's remove the 11th element. Int.remove the 0 element. Int.remove the 6th element. So we'll just have 10s left, I think. And do the same thing now. Let's print all of them out. And after we've deleted those, we want to add something again. So I want to push a 100 after that. Push a 200 after that. And then we will just cout the final element by doing this. Int.size -1. That's the final element. And yeah, let's see what happens now. New line, so we can add more stuff. Now, if we get a bunch of crashes, we got a crash because of this. I think that was the only issue. No, it wasn't, sadly. Okay, index, sorry guys. I know you see these things before I do, and you're probably just sitting there like, oh my god, what is he doing? Crazy guy. Okay, so we didn't get any crashes. What we're gonna do, we're gonna do system pause to be able to read anything. We want to do this as well. I want to go in here to my examples thingy. Where is it? Examples, memory leak detect. I'm gonna copy this code and I put it at the top of my main just to see if we're getting any leaks. And I'm gonna run. So we had 20, 40, 30. 20, 40, 30. That worked. Whoops. What the hell? What the hell, boys? Okay. 20, 40, 30. Then we printed them all out. 20, 10, 10, 10, 40, 10, 10, 30. We removed all of them, so we only have 10s left, and the final element's 20. So that worked. Now I'm going to do this with the order delete. So I'm going to do true. Sorry about that, guys. Oh, I'm going to have to let it ring. Okay, so that, let me just see if this works. And then I'm going to answer. So, okay, so that's the order delete screwed stuff up. I think it screwed stuff up. The order delete is just, what's the time? 11? Okay, we're fine. Order delete, we go through, we delete that object. We go through everything until the number of elements. We just point everything, and then this number of elements equals a null pointer. And that should be fine. That should be fine. You know what? I'm going to cheat. Guys and girls, I'm going to cheat because I don't want you to waste a bunch of time. I'm going to go into this other project, haha, and we'll just compare what I did because, oh no, this wasn't it. This wasn't it. I think it was, I think it is example 60. And I think it's this one. I think it's, no, this is the inheritance. I'm sorry about this, guys and girls. Let's go into examples. Let's go into examples. Let's see my final example here. Now, this is his own project. Let's go to 59. Now, I think I closed that one. That's okay. Let's go to 59. Here we go. Let's see how we did it. We, in remove, where is it? Remove pop. Okay, so I deleted it. Oh, that was the issue. Wow, I'm kind of dumb, guys. I think I'm kind of dumb, you know, sometimes. But I'm not gonna hit on myself too much. Loading. Okay, main, because I was kind of scared. The array. What I did wrong was, of course, this. Because first we have to sink it down, and then we're gonna go. But I don't get that though. I don't get that though. Why number? Because at this number of elements, there is nothing. There is nothing at this number of elements. But we'll see. We'll see. Oh, this was the wrong thing. This was actually correct. So we're going from the index and forward. Wow, that was dumb. So let's try this now again. And now it should work. Yeah, 10, 10, 10, 40, 10, 10, 10. Well, actually the 40 didn't work. Actually the 40 didn't work. I think that could be because of this, but it shouldn't. Like, it should just, I mean, it should just do this. Yeah, that didn't really matter. That is weird. So it removes 11. Removes that with true. So we delete that thing at the index. Oh wait, yeah, because now it's ordered, right? So once we delete, this is fine. When we delete 0, we're gonna delete the 10 instead. So to remove the 40, I'm gonna have to do 5. There we go, guys and grills. There we go. Now it's gonna work. 10, 10, 10, 10, 10, 20, bam. Okay, we're good. Sorry about that, guys. Sorry for all the confusion, all the errors, but this is a much more efficient kind of a thingy. So you just want to remove these to get the max aficionado stuff. And the way it's efficient is we don't have to all the time go in and loop through all the elements. Imagine having a bunch of elements. You can just delete it so quickly, and you can just kind of push stuff in quickly as well. And you can you can get stuff out quickly because we'll just have at the index. So that's good. Thanks for watching, guys, girls. Take care, and I'll see you in the next one. All right, bye bye.